Our universe is a place of wonder, a vast expanse that stretches beyond our wildest imaginations. It is filled with billions of galaxies, each containing billions of stars, planets, and countless other celestial bodies. But it wasn't always this way. There was a time when the universe was a dark, empty void, a blank canvas waiting to be painted with the light of the first stars. Let's journey back to a time when the universe was young, a time when the very first stars began to shine, igniting the cosmos with their brilliance. This is the story of the cosmic dawn, the birth of the first stars that would light up the universe and set the stage for everything that was to come. Imagine a universe bathed in darkness, an expanse of hydrogen and helium gas, the building blocks of stars yet to be born. This was the canvas upon which gravity would soon work its magic, pulling these gases together to form the first stars. Out of this primordial soup, the first stars emerged, blazing with a brilliance never before seen, illuminating the darkness and bringing light to the cosmos. These celestial pioneers would forever alter the destiny of the universe, their light and energy shaping the very fabric of space and time. Their light pierced the darkness, signaling the end of the cosmic dark ages and heralding a new era of cosmic evolution. These first stars were not merely points of light, they were cosmic engines forging the elements essential for life itself, elements that would one day become the building blocks of planets and even life. This is their story, a story of creation, evolution, and the enduring power of the cosmos, a testament to the incredible journey from darkness to light. Our journey begins with the Big Bang, the event that marked the birth of our universe. In a fraction of a second, the universe expanded from an infinitesimally small point to an incomprehensibly vast expanse. As the universe cooled, energy transformed into matter. The first elements to form were the simplest and lightest hydrogen and helium. These elements spread throughout the early universe, creating a vast, diffuse cloud. This cloud, though seemingly insignificant, held the seeds of everything we see around us today. The early universe was a turbulent place, filled with unimaginable energy. But within this chaos, order began to emerge. Gravity, the architect of the cosmos, began to draw these primordial elements together. This marked the first step in a long and awe-inspiring process, one that would eventually lead to the formation of stars, galaxies, and planets. After the initial burst of energy and light from the Big Bang, the universe entered a period known as the Cosmic Dark Ages. During this epoch, which lasted for hundreds of millions of years, darkness reigned supreme. There were no stars, no galaxies, only a vast and ever-expanding sea of hydrogen and helium gas. Yet, within this darkness, the seeds of future brilliance were being sown. Gravity, the tireless sculptor of the cosmos, was at work, pulling together clumps of matter. These clumps, known as proto-galaxies, were the precursors to the galaxies we see today. The darkness of this era was not simply the absence of light, it was a time of immense potential, a gestation period for the universe. Within these dark and silent clouds of gas, the stage was being set for a cosmic dawn, a time when the first stars would ignite and bathe the universe in their radiant light. Section 4. Gravity's Guiding Hand. Gravity, the weakest of the fundamental forces, played a pivotal role in the formation of the first stars. Over millions of years, gravity drew together vast clouds of hydrogen and helium gas. These clouds, initially diffuse and spread out, began to collapse under their own weight. As the clouds contracted, they became denser and hotter. This increase in temperature and pressure was crucial for the next stage of stellar evolution: nuclear fusion. Gravity had set the stage, creating the conditions necessary for the birth of stars. Imagine these colossal clouds of gas, swirling and churning under the relentless pull of gravity. Within their depths, a cosmic drama was about to unfold, one that would transform the universe forever. The stage was set for the ignition of the first stars, a pivotal moment in cosmic history. Section 5. Igniting the Cosmic Engine. Deep within the cores of these collapsing gas clouds, temperatures and pressures soared to unimaginable levels. These gas clouds, primarily composed of hydrogen, began to contract under their own gravity, pulling in more and more material. As the gas clouds continued to collapse, the density at their cores increased dramatically, leading to a rise in temperature and pressure that defies human comprehension. It was here that the universe witnessed a truly remarkable event: the ignition of nuclear fusion. This process, where atomic nuclei combine to form a heavier nucleus, releases a tremendous amount of energy. The conditions required for nuclear fusion are so extreme that they can only be found in the hearts of stars. Hydrogen atoms, forced together under immense pressure, fuse to form helium, releasing an extraordinary amount of energy in the process. This fusion process is the same reaction that powers our own sun, providing the light and warmth necessary for life on Earth. This energy, in the form of light and heat, radiated outward from the core, counteracting the inward pull of gravity. The energy produced by fusion creates an outward pressure that balances the gravitational forces trying to collapse the star. A delicate balance was struck. The outward pressure from fusion balanced the inward pull of gravity. This equilibrium is crucial for the stability of a star, allowing it to shine steadily for millions or even billions of years. This marked the birth of a star, a giant ball of plasma held together by its own gravity. Stars are born in stellar nurseries, regions of space filled with gas and dust where new stars are constantly being formed. Imagine the power of this process, the unimaginable energy released as atoms fuse together. The energy produced by a single star can outshine entire galaxies, illuminating the cosmos and driving the evolution of the universe. This is the engine that powers the stars, a process that has illuminated the universe for billions of years. The light from these stars travels across the vast expanse of space, reaching our eyes and allowing us to glimpse the distant past. The first stars, fueled by this cosmic engine, blazed with a brilliance that pierced the darkness of the early universe. These ancient stars were the pioneers of the cosmos, their light marking the dawn of a new era in the history of the universe. Section 6. Giants of the Early Universe. The first stars were not like the stars we see today. They were unique, enigmatic, and far more massive than the stars that populate our current night sky. These primordial giants were colossal, hundreds of times more massive than our sun. Their sheer size and mass made them incredibly powerful and influential in the early universe. These stellar behemoths lived fast and died young, burning through their nuclear fuel at an astonishing rate. Unlike the stars we see today, which can burn for billions of years, these early stars had much shorter lifespans. Their lifespans were measured in millions, not billions of years. This rapid life cycle meant that they quickly exhausted their fuel and ended their lives in spectacular explosions. Despite their short lives, these early stars played a crucial role in shaping the universe. They were the architects of the cosmos, influencing the formation and evolution of galaxies. They were the first factories of heavy elements, forging elements like carbon, oxygen, and iron in their cores through nuclear fusion. These elements are the building blocks of planets and life. Through the intense heat and pressure in their cores, these stars created the essential elements that would later become part of planets, moons, and even living organisms. These elements, essential for life as we know it, would be scattered throughout the universe upon the stars' deaths. When these stars exploded as supernovae, they seeded the cosmos with the ingredients for future stars and planets. The light from these first stars also had a profound effect on the surrounding universe. It illuminated the cosmos, bringing light to the dark primordial universe. It ionized the neutral hydrogen gas that permeated space, a process known as reionization. This process was crucial in transforming the universe. This reionization transformed the universe from a dark, opaque state to the transparent universe we observe today. It marked a significant turning point, allowing light to travel freely and enabling the formation of the complex structures we see in the cosmos now.